Here are some examples which are not exactly of the simple basic form that we're going to find on the table, but we can make a pretty quick substitution to get them into that form. So these are u-substitution problems. Basically, what we're doing here is, as you recall, kind of undoing the chain rule, right? Because if I look at number 10 here, if I were to take the derivative of something like that, right, I would always, with the chain rule, have to take the derivative of what's inside. So that by itself is not going to appear on the table. So what I want to do when I do the u substitution is kind of undo that. So if I was thinking about what's the function inside, the inside function would be the 5 minus 3x. The outside function would be the x to the 10. So I'm going to make the substitution that u is the inside function. And then what I'm going to do is I'm going to change all of the x's to u's, right? So clearly I can put in u inside the parentheses, but also I have this dx. So I have to always substitute for the dx. So then I do du dx here is minus 3. So du is minus 3 dx, or dx is negative 1/3 du, right? If I'm just going ahead and substituting. So now I can substitute the whole thing that's in the parentheses. This is now u to the 10th. And then for dx, I substitute negative 1/3 du. I can pull out the negative 1/3 because that's just a constant, right? Now u to the 10th du, I know how to do that. That's easy, right? That's going to be u to the 11 over 11 when I take the antiderivative. So now I've taken the antiderivative. I'm done with my integration process. I throw in my plus c because it is, after all, an indefinite integral. I'm still not done though, because I started with an x as my variable, so I have to substitute back in for my x. So what I'm going to get as my final answer is this 5 minus 3x to the 11 plus c. Okay, as always, we can check by taking the derivative, and I'm going to do that here just because it will enable you to understand like why we're doing this way. So if I do the derivative with respect to x of this thing, 5 minus 3x to the 11, I'm going to get this, and then I do 11 times 5 minus 3x to the 10 times the derivative of what's inside the parentheses. See, there you go. So then what happens? This is just going to be a minus 3. So this guy, this and that and that and that and that cancel, and I end up with precisely what I wanted, which was that. Now I'm not going to check it every time, but you can always check if you're not sure if you got the right answer. But I'm doing it at first, the first couple when we do it, it's always good to get that idea. Now later on in the class, we'll be able to do ones like this in our head, but perhaps not quite yet. So we're just going to continue on this one. Now, again, though, thinking about the fact that we're undoing the chain rule, this totally makes sense because whenever I have e to the u, I'm used to saying that the derivative of e to the u is e to the u du. I'm going to take the derivative of what's in the exponent. So here my choice is to take whatever's in the exponent, and that's my u. And then du dt is going to be minus 4t cubed. And if I want to now think about, I have to solve for the dt. So I can do du equals minus 4t cubed dt, or du 1/4, I'm going to do minus 1/4 du equals t cubed dt. Now I'm going to show you what I'm going to do. because I always do it this way. I could have put, if I wanted, well, let me see. I'm just gonna do it my way and then I'll do it the other way, right? So here, this t cubed dt, you have it here, right? So I can rewrite this as e to the minus t to the fourth times t cubed dt. And then I'm just going to shove that guy right in there. So I've got e to the u times minus 1/4 du. And now I'm basically done. You know what? What I ought to have done is this so that it had more space. Let me try that. All right. And then I can write my answer a little bit nicer here. So that I have minus 1/4 e to the u. But what is that really? Minus 1/4 e to the negative t to the fourth. Okay. So some people don't like to do that, at least at first, like with that thing. The way what you can also do if you don't want to do it that way, you can continue. You can do exactly what we did in the previous one. Just solve completely for dt minus 1/4t cubed du. Okay, and sub in. I'm going to put it alternatively this way. If you look at the video and you're like, what happened? If you sub in, you get t cubed e to the minus t to the fourth dt, and then you can keep this t cubed. You can put the u in. You can put in minus 1/4t cubed du here, and then these t cubes all cancel out. Beautiful. And then I have minus 1/4 e to the u du. So you can do this either way. I tend to prefer the first way, where if I know I've got my du, I just look for where it is and solve for that. But if that is confusing to you, rearranging the terms, you can always do it this way too. The important thing is before you evaluate the integral, it all has to be in the variable of integration, which you change from x or t or wherever you started to this u. And then when you're done, you have to go back. So so that we can see. There's my answer. Let's see, this t looks better. Yeah. Okay, let's do one more straightforward one. So straightforward as mud, right? But again here, similarly to what we had in the previous problem, perhaps, you've got some choices. I mean, in all of them, you kind of have some choices, but the choice is clearer in some than the others. And in this one, the choice might not be as clear as the choice was in the previous one. So the question then is, do I want u to be z squared or u to be z cubed plus 1, for example? Well, if you're not sure, you just try it and see if anything good pops out. So if I do du here, du dz, this is going to be 2z dz, whereas on the other one, I'm going to get du is equal to 3z squared dz. Okay, so if I look at what's going to work better, if I've got, let me just put this one's in blue and this one's in green, we can see that the blue one I can't really get into a z cubed, right? I can't really substitute that. Whereas if I choose the green choice, okay, I can substitute that whole z cubed plus 1 business, or, and then there's a z squared on there, so that substitutes really easily. So that tells me that this is the choice that I want to make, and this guy is not really going to help me very much. Now, you'll notice also that I chose not just the z cubed, but the z cubed plus 1 there. Yeah, if you put z cubed, it would simplify, but you'd still have something with a plus 1 in the bottom. Um, I think you can totally do that way. It'll do the same thing. So that one we'll put that as an alternative. Let's just explore that. Okay. We'll put that as red. So this seems like it might work too. Okay, but let's go with the green to start out with. I probably have a little bit more space if I rewrite it down here. All right, so you can see have to be a little bit careful because I got that 3. So let me just plop that 3 over here. This is z squared dz. So z squared dz, I've got z squared dz right here in the top, right? These guys right here. There's my z squared dz. So this is going to become my du. So basically I'm going to, let me just maybe make it clearer if I write it a little bit. I can pull that there, okay? And now that whole bottom is u, and then this would be 1/3 du, right? So then I have 1/3 integral of du over u, which is, we know, natural log. And so throwing back in my u, I can do 1/3 natural log z cubed plus 1, and I'm done. Yay! So that's probably the best way of doing it because um, on our table, right? On our table, we have natural log of absolute value of x. We have du dx over x goes to natural log of absolute value of x. If I make this substitution here with the I circled in um, red, let's see. Let's just do it in red. Z, let's see what I had. 1 over z cubed plus 1 z squared dz. So then I'd have 1 over u plus 1 times 1/3 du. So now I have 1/3 du over u plus 1. So that doesn't show up on our regular, like our table of basics. Technically, you could make another substitution. Let t equal u plus 1, dt then is du, then this becomes 1/3 dt over t, which becomes 1/3 natural log of t. I'm sorry, this has become a real mess. But, and then you could keep going, like, and then you would get the same answer, I guess is what I'm trying to say here. Let me write that a little bit clearer. So let t equal u plus 1, dt equal du, and then this would be 1/3 ln of t, okay? And then you would have to substitute back again, and you would have to substitute back again. So yes, you could do that. So I put this question mark. Yeah, you could do that because the major guy is the z cubed, but I didn't, because of that extra +1 that was hanging out there, it took me a little bit longer. I had to do another step. So I would say, okay, if you want, you'll get there in the end. If you have to do extra work, ain't no problem there, but it's not as efficient as our green, which got us pretty much right there to my answer. But you will notice that will happen in this class. People can do a thing in different ways and get the right answer anyway.